So I'm Gabriel David. I'm in charge of the two Biolabs here at Soleil. I'm also in charge of the Microfluidics R&D, and I'm the biosafety engineer for all the site. Here we are at the Synchrotron Soleil, where we use the synchrotron beam. And so this is a photon beam, very intense, very brilliant, which we use to analyze samples from different fields, so life science in my case, but also physics, chemistry, archaeology, environment, and so on, geology, and with different techniques, so diffraction, diffusion, spectroscopy, imaging. The idea is really to provide all these techniques to the users community to characterize their sample from their project. To get more in detail about the synchrotron facilities is the generation of electron, then they are accelerated. Once these electrons are at the right velocity, direction, divergence, or so on, they are injected in what we call the storage ring, and from that we use all these parameters to produce this photon beam by the electron deviation. And then with this photon beam, which is white beam, and very intense. These are the start of the beamline, so these mini labs with, as I said, different energy range and techniques. So why is it interesting compared to lab technology? It's because you're going to have this wide beam, so you can really choose a wavelength from a very large field, from the UV to very hard X-ray. And then, of course, it's very intense, which means higher resolution, spatial temporal resolution. As I said, I'm the head of the Biolabs, which are two support labs dedicated to scientists who are coming to analyze samples at Soleil. And then, specifically in life science, as we know that the samples are fragile, we thought that it would be a good idea to offer these two spaces to finalize, to prepare the samples before analysis on the beamline. So there are two biolabs, one which is the Biolab 1, dedicated to BSL-1 safety level, and which is dedicated to characterization of macromolecule in solution. And the second one is the Biolab 2, which is dedicated to bacterial activities. From biomolecular to purification steps. I talked about the two biolabs. There is also a microfluidic lab specific to internal prototype development. We have two rooms. This clean room where we can prepare the microfluidic chips, where we can make and characterize the chips. And then we have what we call the preparation room, when we can test the chips. So we can include them in the dedicated sample environment, and we can connect the chips and test there's no leak, the way it functions, and if it's okay. So I'm a biochemist, biophysicist, and I've always been interested by the R&D development for sample environment. And then since I would say 10-15 years, I'm really working on microfluidics, so all the steps from the microfluidic setup environment a bit more dedicated to secondary facilities, which means microfluidic design, setup, fabrication, to include this in a sample environment, and then also to connect it and to generate a flow inside the chips. 15 years ago now, I've been in a conference in Switzerland at Montreux, and I met for the first time the Elveflow company with the demonstration of the pressure pump. And this sounds to be very interesting at that time. So I invited them at a conference here at Soleil with my scientific colleague. And from that time, I think that I started to switch my way of thinking how to generate a flow rate. So we have different scientific field, in life science or in chemistry. So for the microfluidic development here at Soleil, we know the basic way to generate a flow, which is using a syringe pump or a classic pump like HPLC pump or peristaltic. But this is with a fixed volume, which is not easy. And most of the time you have a problem with pressure. And I would say that the pressure pump is very interesting for life science because if we keep in mind that the biological samples are fragile, it's better not to force these samples to go through a pump. For chemistry, this is also interesting because if you have some aggressive reagent or reactive reagent, it's better not to go again through a pump. I also wanted to use one of the Elveflow system, so the OB1, for one of my collaborative projects. The main aim is to generate a train of buffer droplet, and then the idea is to encapsulate living cells. Once this is optimized, we want to cryoconserve these encapsulated cells with the aim of gene therapy, and we use effectively this Elveflow pressure pump to generate the train of droplet for the first time, and then we can have additional input for the cells and then for the cryoprotectant and something like this, which is very interesting. We are working on the design of the microfluidic chips, and we use specifically this pressure pump because it's very easy to use as a pressure generation. Once you start the pressure, you have a flow. When you stop the pressure, the flow stops. And this is very important for us. So another project is in chemistry. It's on a liquid microjet on a beamline. So this is a complete setup implemented on a beamline as a sample setup environment. And so the idea is to generate liquid microjet on the vacuum. And this means smooth, stable flow using, I would say, chemical reagent, of course, but sometimes aggressive or really sensitive reagent. So we needed an equipment to generate the flow, which avoids contact with the solution. So the pressure pump is the best way, and in that case, it made a difference. Specifically in life science, we need to reduce the volume for different reasons. You may know the fragility, the prices, sometimes consuming. We want to optimize the volume, dedicated volume to analyze. And if we talk about Soleil, we started the project of Soleil 2, which is an upgrade. We will have, of course, smaller sample setup, micron setups. So, of course, microfluidic will be included in and involved in this kind of project. I would recommend Elveflow. Main thing is the on-off, which is completely different in the case of the syringe pump and the peristaltic pump and so on. And the fact that the solution, the reagents, don't see anything before they are analyzed with different techniques, but especially for us, for the synchrotron application. The other thing is the software, quite easy to use. The installation, the recognition of the equipment by the software is easy with the USB system. I will recommend Elveflow for these two aspects. I would say the scientific aspect and the control aspect.
Great, thank you.
So thanks you.
Thank you very much.